Welcome and hello. This is a video exercise in HEC ResSim, and in this exercise, we're going to be doing some utility scripting, specifically to write some scripts to display a plot on the screen after a simulation. Okay, so let's go ahead and get started. What I have is ResSim up on the screen. I have the watershed setup module selected here. So just if you're following along, go ahead and go File, and then click New Watershed. Give your watershed a name, and then click Select Location button, and this is where you specify the directory you want your watershed directory to be created in. Select the units, and then the time zone, and then Apply, and then OK. Okay, so we have our watershed created. I'm going to zoom in a little bit, and then click the Stream Alignment tool, hold down Control, and then single left click, continuing to hold down Control, and then finally, before my last click, let go of Control, and then give the stream a name. All right, I'm going to add a computation point here at the upstream end by holding down Control, single left click. I'll call it a CP1, and then select the reservoir tool, and we're going to add a reservoir downstream of CP1. I'm going to hold down the Control key again, and then single left click on the upstream end of the reservoir pool, let go of Control, and then single left click again where you want that dam face to be. So we'll call this reservoir 1. All right, let's add one more computation point down at the end, or towards the bottom of the stream alignment. So single left click after holding down Control, and we'll call that CP4. Great. Next, let's go Watershed Configuration Editor. Let's create a configuration based on these elements here. So I'll just call this config1. Time step is 1 hour. That's not used by ResSim anyway. Apply, and then OK. All right, File, Save Watershed. We're good there for the watershed setup module. Next, we'll select the reservoir network. And the first thing we need to do here is create a network. So network, new. Now I'll call this network 1. And then for configuration, I'll select the configuration, config 1 that I just created. So when I click new, then my reservoir and the junctions appear on the screen. Okay, next let's go with the reach tool here. And then from upstream to downstream, we want to draw in our reaches between adjacent junctions. So hold down Control, single left click on the upstream junction, let go of Control, and then click again on the next downstream junction. That's CP1 to CP2, and this is CP3 to CP4. So I've got 2 reaches in 1 reservoir. Next, let's go ahead and add some inflow in that upstream junction. That's CP1. So right click, Edit Junction Properties. I got CP1 selected here. Then I'm going to click the Local Flow tab. And then on the first line here, I'm just going to call this inflow at CP1 with a factor of 1. Apply, and OK. Next, I want to actually define what that inflow is. So to do so, we're going to create a time series data set. Let's start by going up to Tools, HEC DSS View, and then File, New. I want to create a .dss file first to contain that data set. So I'll call that time series data.dss. Okay, so our DSS file has been created here. Now let's go up and go data entry manual time series. And then here I'm just going to type in some generic terms like project, location, flow. I'll call this CP1 for part F. So if you actually had a project name or a river basin and then the actual spot along the river basin or so on, you would fill those values out accordingly. I just kind of use placeholders. Let's go with the month of July 2024. And the start hour would be the first hour of the month because this is going to be in 1 hour increment on our time series. For units, let's go CFS, and then instantaneous value would work, or period average. Next, all we have to do is fill out the actual values themselves. So I have that saved on my clipboard. I'm just going to right click paste, and then those are my values. It is hourly flows. It starts at 2550 and ends at 2550, but we do have a peak here, which I'll show you in a plot. So I'll just click save and then no. Select that record we just created, and then here is the plot. So it's basically just like a hydrograph with a peak here at about July 8th, July 7th at close to 18,000 CFS. But our base flow is down here at 2550 CFS. File, tabulate, and then here are the values here. Okay, let's go ahead and close that up. We have our inflows ready to go, so we'll assign that a little bit later. What I want to do next is add some reach routing. So I'm going to go up to Edit, Reaches, and then we have two reaches here, CP1 to CP2, and then CP3 to CP4. So for both of these reaches, I'm going to go ahead and add Muskingum routing. I'm going to type in some numbers here, K, X, and N values, then click Apply. Let's do the same routing for CP3 to CP4, Muskingum again, and then, okay, so the same values that I already typed in are here, that's good, and then Apply. So we have some routing in both the reaches, that's good. Next, let's go ahead and edit the reservoir. So we can go Edit, Reservoir, and then let's see, I can select the reservoir here up at the top, and there's only one reservoir, so that's trivial. Okay, so here is the pool data. I'm going to paste that in. You can type it in, but I had it copied onto my clipboard. So we have the elevation, the storage, and the area of the reservoir. The elevation goes from 1350 up to 1500. Okay, so I'm going to go ahead and click Apply. And then the dam has a top elevation of 1500. We just type that in. And then I'm just going to make a top of dam length. And then right click and adding a controlled outlet. Okay, I'm going to just paste in my data for the controlled outlet. It shows the max capacity versus the water surface elevation in the reservoir pool. I'm going to stick with one gate here, and then I'll apply. Next, I want to add an uncontrolled outlet, which is like a spillway. So just add uncontrolled outlet. This is going to have an invert of 1450. And then I'll select this elevation versus outflow radio button and then paste in my values, starting with 1450, having a flow of 0, and then increasing flows as the elevation of the water in the reservoir pool increases. Click Apply. Next, I want to head over to the Operations tab. I'm still in my Reservoir Editor dialog box, but now I'll go Operations New. The first thing here is to create an operation set. All right, operation set 1 is fine for a name. And then it gives me my 3 zones. I can add more zones and make things fancy, but for this exercise, I just want to kind of keep things simple. So let's go with a top of flood control zone of 1500. Apply. The top of the conservation zone is going to be 1450. Apply. And then the top of the inactive zone is going to be 1400. Apply. I'm not going to use any rules for this exercise. So the guide curve elevation of 1450 is what the ResSim is going to try to maintain that water surface elevation at in the reservoir pool. Next, let's go up to Alternative, Edit, and then Alternative New. We're going to just call our alternative base for a base case based on network 1. Okay. We're going to go with a time series of a 1 hour time step. And then let's see, operation set 1, the look back tab. We have to type in the 1450 is going to be our look back water surface elevation in the reservoir. The release is going to, from the controlled outlet, is going to start at the base flow, which is 2550. And then out of the uncontrolled spill, it's going to be 0 because the water surface starts at 1450, which corresponds to 0. All right, the last thing we have to do here for the alternative is go ahead and reference our time series to CP1. So we do that here in this time series tab. I'll select the record and then click select DSS path. Now we want to navigate to that time series data.dss file we created. Select the record, click set path name, and then close. All right, so that assignment's been made. Let's go ahead and save our alternative. And then I'm going to go ahead and save this network. All right, time to go to the simulation module. So let's select that and then simulation new. I'm going to call this simulation 1. This is going to be for the month of July 2024. The start period is going to start on the second hour, and then the look back will be starting on the first hour of the month, and then the end date time for the end of the simulation will be on the last hour of the month. Next, I'm going to select this checkbox in the bottom for the base alternative that we created, and then click OK. Here's our network that we've seen before with our inflow, our reach, reservoir, reach, and we have 4 junctions, CP1, CP2, CP3, and CP4. So I'm going to click this compute base, And then we're good. The simulation has run. Let's just double check to make sure our numbers are looking good. Okay, what we have in the top plot is elevation versus time. So we see the water surface elevation starts at 1450. It increases up to about 1480 and then drops back down to 1450 again, which is a result of this inflow. What we're seeing in the bottom plot is inflow, where we have a huge peak in the inflow, and then of course the release is in green. So we see how the routing takes place of that huge inflow through the reservoir. All right, so what we want to do in this exercise, since we've got already well into the video, is to create a few scripts, write scripts that will actually generate plots just like this one. So we can obviously right click on the reservoir and click plot, but maybe we want to look at something different. So I'm going to take you through three fairly simple examples of clicking a button to invoke a script and then seeing a custom plot on the screen. We're going to stick in the simulation module for this, and then we're going to start off by going Tools and then Script Editor. Okay, I'm going to select Simulation here, and then New Script. I'm just going to paste in plot CP1 flow. For a description, I'll say this plots the flow at CP1. So this is almost trivial because you can just right click on that CP1 junction and look at the plot. But this is sort of our hello world example, our very first example of displaying a plot based on clicking a button to invoke a script. All right, and so to save time, I'm just going to paste in the entire script here. One thing I need to do is get the DSS file because that does change with each exercise. I'm going to go back to ResSim, Tools, HEC DSS View, grab my particular file path. I'm going to be reading, this top record here, which is CP1. So let's just take a peek at it. It looks just like the inflow because it is, but on my clipboard, I have that file name copied. So let me just close this and then just paste that value in. So this is the file path. This right here is the CP1 flow for this is the exact path name. So we're getting the flow data. And then in this bottom 3 lines here, what we're doing is we're creating the plot. We're giving it a title, flow CP1, adding that plot, that flow data to right here to the plot, and then showing it. All right, so pretty straightforward, right? Let's go ahead and give it a test and see if it works or not. I don't like testing it in this module. It feels a little bit disconnected from the actual app, but I am going to save it, of course. And then let's just close that. Okay, let's go Tools, Scripts, and then here is our script button. Here, let's try to click on the plot, and here it is. So pretty straightforward. That's not too exciting, but let's move ahead and do a couple more. So the next one, what I want to do is look at the flow through the reservoir. So if I right click and then plot, we've seen this earlier in the exercise. I'm going to focus in on the flows themselves and not the inflow so much, but rather the release from the reservoir. Now, this is the total release from the reservoir, and that's good to know, but maybe I'm curious about the release from the controlled outlet versus the release from the uncontrolled outlet, the spillway. And we're not getting that information here, but that information does exist in the time series dataset. So if I go down to reservoir controlled, here's the controlled outlet release. And then further down, there's uncontrolled outlet release. That's this one here. So I'm going to take those two records, plot them together, as well as the overall reservoir flow, which would be the reservoir 1 flow decision. Okay, so we have our first script here. I'm going to click on simulation again. I can right click, add new script, or I could just come up to file, new, and then that would add a script because I have the simulation directory selected up here. I'm going to give the script a label of plot reservoir 1 releases. So I'll say plots releases from reservoir 1. Next, I'm just going to paste in all the code at once. What I'm doing here is I'm assigning the DSS file. This is the same as the previous script we use. Then I'm going through and getting 3 data sets. There's the release from the reservoir, which is overall, and then the release from just the controlled outlet, and then the release just from the uncontrolled outlet. And then I'm using this get method to get that data into a data set, which can then be read into the plot by using the add curve method. Down in the plot, this looks a little bit more involved. The first line is just the same as before, where I create a plot with giving it a title. And then what I'm doing is I'm creating a layout and then adding a viewport to that layout. And I'm only using one viewport, but this is a viewport is sort of like a, a, a graph or a plot within a plot window. So when we right click plot on the reservoir, there's actually two viewports. This is how you do that if you wanted multiple viewports, but I'm using that sort of coding format, even though I'm only using one viewport here. All right, so go ahead and check that out if you want details. I'm going to leave a link in the description to the information I used for this video with much more information and much more detail about the plots that I'm doing, I'm showing in this exercise. This is just sort of an introduction. But let's go ahead and save it and run it and see if we get the data that we're looking for here on the screen in a plot. So, okay. And then let's go ahead and go back to Tools, Scripts, and hold on a second. Scripts. Okay. So here's the button. I didn't see it before. And let's go ahead and give it a plot. All right, perfect. So what I'm seeing here is the three different releases. Of course, the green is the first series, and this is the total release. And then the red is release from the controlled outlet. So remember that starts at 2550 and it increases, but not all of that total release comes from the controlled outlet, because in blue here, we have a substantial release of about 3600 CFS being released from the uncontrolled outlet as well. All right, so that's the second plot. There's one more plot I want to do similar to the first two, and that is to show the lag and attenuation of this inflow hydrograph at CP1 as it goes through the reach and then through the reservoir and then through the downstream reach. So we've got two reaches, one reservoir, and we're going to see this hydrograph decrease and also delay. Of course, most of the delay and the decrease in the peak elevation will occur in the reservoir itself, but I'm just curious to see what that looks like. So I'm going to basically just create a plot like this one, but instead of CP1 alone, it's going to show going to display the flow at all four junctions, CP1, CP2, CP3, and CP4. All right, so let's head back over to our script editor and then click on Simulation, New Script. I'm going to give it a label here, Plot All Junction Flows. The description will be Plot the flows at all junctions. Now I'm going to paste in the code, the script to make that happen. A lot like what we've already done, we have the DSS file created. I'm grabbing data sets for the flow at all of the four junctions, and then I'm adding that flow down here at the bottom. All right, so go ahead and pause the video if you want to check that out more, but I'm going to move ahead and hit save, and then OK. And then Tools, Scripts. Here's, yeah, okay, so it added that button right here. I'm guessing it's alphabetical. I'm not sure. But anyway, this is the one we just added. Let's click it. And then here we are. So cool. This is pretty much what I expected. In green, this is CP1 flow. And then in red, this is the flow through CP2. So notice it's not exactly the same because of the volume and the storage in that first upstream reach that's upstream of the reservoir. And then blue, this is the total release from the reservoir. So this is a much smaller peak than we had before, because that's the whole purpose of flood control and reservoirs, is to reduce that peak flow and sort of release it at a slower rate over the course of multiple days here. And then yellow is the CP4. Let me highlight it here. There it is, which is essentially the same as CP3. I mean, the peak is almost the same, but it is delayed by probably, I don't know, 16 hours or so. We could look that up, but not gonna. All right, so this is an exercise using utility scripting or static scripting in HEC ResSim. This is one of the more popular, more talked about, or written about uses for utility scripting, is to, after a simulation has run, do some post-processing and analysis by generating scripts. Again, I'll leave the description or the link to some of the documentation I used for this exercise in the description so you can check that out. I am just scratching the surface. There's so many things you can do with these plots that I read about, and I just kind of wanted to do an introduction example to get everyone here watching up to speed, just get the ball rolling and introduce some of the things that you can do here with utility scripting in HEC ResSim.